These problems are no fun to solve by hand, but I'll go ahead and take a crack at showing you how to solve a small one here by hand. Here we're maximizing p equals x1 minus x2 plus 3x3, subject to x1 plus x2 is less than or equal to 20, so I have a less than constraint. And then here x1 plus x3 equals 5, so I have an equal to constraint. And then x2 plus x3 is greater than or equal to 10, so I have a greater than constraint. And then, of course, all of my variables are non-negative. Now, I didn't do this one where you have to multiply any of these by a -1 to convert them, so we can just go ahead and go straight into introducing our slack, our surplus, and our artificial variables. So here, since I have a less than constraint, I'm going to introduce a slack variable there to convert that to an equation. And for my equal to constraint, you just introduce an artificial variable. And then on your greater than constraint, you introduce the surplus variable. So you remember, you take that away, you subtract that one, and then introduce your artificial variable. And then you check and see how many artificial variables were introduced here. So we introduced 2. So we have to actually subtract that artificial variable times big M for each one of these. So we introduce a minus M times A1 and a minus M times A2 for the modified problem. And then we can now take this modified problem and write the simplex tableau for that. And so let's list a column for each one of my variables, x1, x2, and x3. And I have an S1, and then I have an A1, and I have an S2, and I have an A2. I think before I listed the S's, then I listed the A's, but it really doesn't matter. So S1, A1, S2, A2, and then P. And then let's just put in the coefficients. So my first equation is 1x1 plus 1x2 plus 1s1 equals 20. My second one is 1x1 plus 1x3 plus a1 equals 5. And then my third one, I don't have an x1, but I do have a 1x2 plus 1x3 minus s2. So I have a minus 1 here, and then 1a2 equals 10. And then remember, you have to move these terms to the other side of the equal sign to get the last equation. So if I move x1 over, that'll give me minus 1x1. And if I move minus x2 to the other side, that'll give me plus 1x2. And if I move 3x3 to the other side, I'll get minus 3x3. And then when I move my minus ma1 over, that'll give me a positive m for the coefficient of a1. And my minus ma2, when I move it across the equal sign, it'll give me a positive ma2. And then, of course, I'll have the 1 for 1p and then 0. Now, we're not going to do the simplex method yet. Remember, what we have to do is we have to get rid of these m's that's below these two columns. So we got to get rid of this m that's below the a1, and then we get rid of the m that's below the a2. So we have to do that first. So to eliminate the m that's below the a1, I can actually use the second row here. That way, if I multiply this row by negative m and add it to this row, it'll cancel the m. So I'll do a little bit of this for you. Negative m times 1 is negative m, add it to negative 1, and we get negative m minus 1. Negative m times 0 plus 1 won't change that. Negative m times 1 would be negative m minus 3, would give me negative m minus 3. And then negative m times 0 plus 0 is 0, so that's going to be here. Negative m times 1 plus negative m is going to give me 0, so that's going to be here. And then negative 0 times 0 plus 0 is 0. Negative m times 0 is 0 plus m is m. Negative m times 0 plus 1 is 1. And then negative m times 5 is negative 5m plus 0 gives me negative 5m. Now, I still need to eliminate this m. And so I can use this row to eliminate it. So multiply row 3 by negative m and add it to row 4. And then, of course, negative m times 0 added to this won't change it. Negative m times 1 would give me negative m plus 1. So negative m plus 1. Multiply this by negative m and add it to this, I'll get negative 2m minus 3. Multiply this by negative m, it's not going to change anything, so I'll still have 0 there. Same thing here, it's not going to change anything, so I have 0 there. Negative m times negative 1 is going to give me m, so if I add it to 0, I'll just get m. And then negative m times 1 plus m is going to give me 0, and negative m times 0 plus 1 is 1. And then negative m times 10 would be negative 10m. Add it to negative 5m, I'll get negative 15m. Now that we've eliminated those m's below the artificial variables, we can start the simplex method. I know you might look at this and say, well, don't we have to eliminate this? No, we only have to eliminate the m below the A1 column and the A2 column. Then we can start the simplex method. So ask yourself, what would be more negative? Minus 1,000,000 minus 1, minus 1,000,000 plus 1, or minus 2,000,000 minus 3? So I think common sense tells you that minus 2,000,000 minus 3 would be more negative. So we would pivot on this column. And then remember, we can only use the positive numbers up here to determine the pivot row, so ignore the 0. And then 1 goes into 5 5 times, 1 goes into 10 10 times, so the smaller quotient would be in row 2, so we would actually pivot on this row. Now, I'm not going to go through all of the arithmetic here from here on out. I'm just going to show you the process, but we don't have to do anything to get a 0 here. Here, you're just going to do minus row 2 plus row 3, and I think everybody knows how to do that, and that'll give you the 0 right here that we need. And then, of course, it'll change all the other values in row 3. And then to get rid of the minus 2m minus 3, you'll have to multiply row 2 by the opposite. So what's the opposite of minus 2m minus 3? It would be positive 2m plus 3. So we're going to multiply row 2 by 2m plus 3 and add it to row 4. Now, if you do that, I'll walk you through that. If you multiply 2m plus 3 times 1, you get 2m plus 3, and then you add it to this, and 2m minus m gives me m, and then 3 minus 1 gives me 2, so I'll get m plus 2. If I multiply this, it's not going to change anything. I'll just get 0, and so it won't change that. And if I multiply this by 2m plus 3 and add it to m minus 3, it'll just give me 0. It'll cancel that and give me 0. And then if I multiply 0 by it and add it to 0, it's still going to be 0 under the S1 column. If I multiply this by 2m plus 3 and add it to 0, I'll just get 2m plus 3. Of course, if you multiply this by 2m plus 3, it's not going to change anything. You'll still have m there. Same thing here, you'll still have 0 there. And the same thing here, you'll still have 1 here. But when you multiply this by 2m plus 3, 5 times 2m plus 3 would be 10m plus 15. So if you add 10m plus 15 to negative 15m, you actually are going to get negative 5m plus 15. All right, so now let's see where my most negative indicator is now. M plus 2 is not negative. 2m plus 3 is not negative. And so negative m plus 1 is the only negative indicator, so that's got to be my pivot column. So negative m plus 1 is my pivot column. And again, I can't use the 0, so we divide 1 into 20 and we get 20. Divide 1 into 5, we get 5. 5 is the smaller quotient, so this would be my pivot row. Now, I think you all know how to do multiply this row by negative 1 and add it to row 1. So everybody knows how to do that row operation, minus row 3 plus row 1. So, you know, that'll just give you the 0 here, and of course it'll change some of the other values. We already have a 0 here, so we don't have to worry about that. But we do have to multiply this by the opposite of what we have down here. Since I have minus m plus 1 down here, I've got to multiply this by m minus 1 and then add it to this row. So if I multiply everything in this row by m minus 1, that'll be, multiply this by m minus 1, I'll get minus m plus 1, and if I add it to this, I'll just get, the m's will cancel, and I'll get 2 plus 1 is 3. If I multiply this, of course, it'll just cancel this when I add it, so I'll get 0. And then, of course, here, I'll just get 0 plus 0, which is 0. Same thing here, I'll get 0 plus 0, which is 0. If I multiply this by m minus 1, I'll get minus m plus 1, and if you add it to this, 2m minus m is m, and then 1 plus 3 is 4, so you get m plus 4. And then here you'll get minus m plus 1, and then if you add it to this, the m's will cancel and you'll just get the 1. And then here m minus 1 times this plus this will give you m minus 1, and then multiply this by m minus 1, you'll still get 0 plus 1's 1. And if you multiply this by m minus 1, you'll get 5m plus 5. So no, you'll get 5m minus 5. So you'll get 5m minus 5, and then if you add 5m to minus 5m, it cancels, and then if you add minus 5 to 15, it'll give you 10. Okay, now I don't have any negatives because I know m plus 4 has to be a positive number, and a million minus 1 certainly would be a positive number. So I don't have any negatives on the bottom row. So now let's just look for my basic variables. x1 is basic right there. No, it's x2. x2 is basic. x3 is basic. s1 is basic. So those three are basic variables. The only other basic variable I have is the p. And you know what I'm looking for? I'm looking for the columns that have the zeros and the 1. So so these others are non-basic. So that means this is a non-basic variable, and these are non-basic. So now we know x1 is 0 since it's non-basic, so we can go ahead and write that down. And then from this column, the 1 is in the third row, so we know that tells us x2 is 5, so that'll give us the x2 value. And then x3, the 1 is in the second row, and that also tells us 5, so that tells us x3 is 5. And then of course, as I said, a1 is 0 and s2 is 0 and a2 is 0 because they're non-basic. And then if you want to know the s1, it's actually in the first row, so that's 15. And then of course the p is 10. And then your maximum value here would be p equals 10 when x1 is 0, x2 is 5, x3 is 5. Now, wasn't that so special? I'm going to work one more problem for you in this section. I'm going to work an application problem that has mixed constraints. And don't worry, it's not going to be too difficult once we get it set up.